So let's go over some quick vocab that you'll hear me using in this video. The first would be parallel lines. Parallel lines, I think you all visually know what those look like, but they're lines that have the same slope and would never ever meet. So in each of these diagrams, you're going to have one pair of parallel lines. If we look at this first one, well, these would be the lines that would never touch. So that would mean they would have the same slope. And then over on the diagram on the right, we have the pair of parallel lines over here. So it doesn't matter which way they're facing or anything like that, but we're always going to see one pair of parallel lines. The other line is a new word to you that's called a transversal. So a transversal would be that other line that's kind of cutting through them. So the official definition would be a line that crosses through other lines. So that's what we have here. Some line that's cutting across that pair of parallel lines. So a lot of times you'll see something regarding you have a pair of parallel lines cut by a transversal. If you have your math notebook at home with you, these might be good things to kind of label. Maybe draw yourself a picture and label this as the transversal. And then sometimes for parallel lines, you'll see these little arrows like this, and those would represent that they have the same slope. So our goal over these next few days would be to first learn the specific angle pairs that are created by these diagrams or created by parallel lines cut by a transversal. Once we start to master that, we'll then move on to, well, what do we know about the measures of those angles? And how can we use what we know to maybe solve for missing things? So if we look at this example of the parallel lines cut by the transversal, there are 8 distinct angles that are created. Here they're labeled A through H. Okay? So we're going to use that figure to help us start to create labels of these angles that are happening. The good news is, while they have fancy names, the names are really describing the location of these angles on that diagram. So I'm going to walk you through that next. So the first way to describe where angles are is in regards to where they are compared to the parallel lines. So if we look here, the parallel lines that we're talking about run this way. So if we think about where those can be, when we're talking about comparing them to the location of the parallel lines, we're really focused on, well, are they here? And that would be kind of sandwiched in between those parallel lines. Or would they be out here? So let's look at some specifics. So the first 4 that we're going to look at, in compared to those parallel lines, are kind of on the outskirts. So they're not in between them. Instead, they're on the outside of the parallel lines. So how we describe outside the parallel lines is just with a slightly fancier word of exterior. So if lines are not in between the parallel lines and instead they're kind of off to the side of them, we call those exterior angles. So A, B, G, and H would all be exterior. I bet you can probably figure out what we call the ones inside the parallel lines. So if they're inside like these are, right in between those parallel lines, we call them interior. So C, D, E, and F would all be inside those parallel lines, so we call those interior angles. The next way to describe angles' locations would be in regards to where they are compared to that transversal. So the first thing I'm going to do to help us is just to quickly highlight the transversal on all of these. Remember, that's the line that cuts through those parallel lines. Okay. So let's look at these first 2. It says, describe the locations of the angles to each other. So I have B and H. Well, if I'm specifically looking at where they are in regards to the transversal, I have one on each side. B is kind of to the top of that transversal, and H is on the bottom. So I have one over here, one over here. Same thing happens with C and E. I have one on this side of the transversal, and I have the other on this side of the transversal. A fancier way, they're kind of on opposite sides. in regards to the transversal. So how we say that in our, again, slightly fancy way would be that we call those alternate angles. Just spelled that wrong. So B and H would be alternate angles to each other, and same thing with C and E. They are on alternate sides of that transversal. So if we look at the next few, we have D and E and B and G. Well, now we only have one side of that transversal. So instead of being alternate sides, they're on the same side. So a way to describe D and E to each other would be they're on the same side of that transversal. Same thing with B and G. There are some differences though. D and E and B and G are slightly different from each other. D and E are not the same exact pair that B and G are. So next we're going to look at how to compare these last two things that we're talking about to create these very specific angle pairs. All right, so now we're going to attempt to put everything together and try to describe two angles as specifically as we can. Okay, the first two are going to be a throwback, so actually using the 7th grade material that we hopefully feel pretty good about. So first, I'm going to look at angle A and angle B compared to each other. So if I look at A and B here, I see that they are right next to each other, and together they make a straight line. So A and B are our supplementary angles. Since they are right next to each other and they create a straight line, you might also hear them being called straight angles. So I'll write that too. All right, next up, again as a throwback, we have angle A, and directly across from it we have angle C. So when they are across from each other like this, we know that they are equal, and we call those vertical angles. So we still have a couple old familiar favorites in this new complex diagram. All right, so moving on to some new ones. We talked about how to describe them in regards to the transversal and in regards to the parallel lines. Their name really comes from putting those two pieces together. Okay, so to help us, I'm going to just make some quick highlights, pointing a couple things out. First, I'm going to highlight that transversal because that will be important for us. And next, I'm going to highlight the parallel lines. Because remember, our names come from describing where they are compared to those two things. Okay, so the first that we're going to look at, and I'll try to color code these because you know me. First, we have angle A and angle H. So I need to find both of those. And then we're going to attempt to describe where they are. So in regards to the transversal, remember we're talking about, well, are they on the same side as each other or are they on different sides? So here A and H are on different sides of the transversal. Remember we call that alternate sides. Next, I need to talk about, well, where are they compared to the parallel lines? Remember we talk about, are they in between them or are they on the outskirts? Here, they're on each side. They're not in between them. So remember we call those exterior angles. Believe it or not, your final way to describe these is just putting those together. So A and H together are alternate exterior angles. You may want to pause this video and see if you can figure out the others, but I'm going to keep going. So now I'm talking about, what about A and G? So still looking at A, but this time comparing it to angle G. Starting with my transversal, this time they are on the same side as each other. So I call those same side. And then A hasn't moved, so those are still exterior angles. So again, our official name for talking about A and G are same side exteriors. All right, moving along. Next, I'm going to look at D and F. So I need to find D and F. Starting with the transversal, I have one on each side of it. So again, we call those alternate. But this time I've moved in between the parallel lines. So now I have interior angles. So putting those together, when I'm talking about D and F, I say that those are alternate interiors. And then my last example here, we're going to look at D compared to E. So this time D and E, those are on the same side as the transversal. And they are inside of the parallel lines, so I say those are interior. So my final type of relationship that I have here are same side interior. If you have a printer at home, I'm going to upload a file of this exact page for you to maybe print off to have as a reference. I think it's a good kind of tying everything together example. Okay, so we have a diagram here. We have our 8 angles labeled. We also have the helpful reminders to look at. Are they interior, exterior? There's that transversal labeled, so we can make sure we're thinking about, are they on different sides or are they on the same side? So we're going to go through these and just identify one example of each. So starting with our old ones, we have supplementary angles. Together, those make a straight line. They're next to each other. We have a ton of examples here. Even just looking at that left-hand side, I have 1 and 2. I could go around and do 2 and 6. 5 and 6, maybe 1 and 5. So I'm just going to do the first one that came to my head, which was angle 1 and angle 2. So together, those are supplementary. Same thing with vertical. I have a lot of options here. As far as angles across from each other, I could do 1 and 6, 2 and 5 would be vertical, 3 and 8, or 4 and 7. So again, I'm going to stick with just the first one I saw, which was angle 1 and angle 6. All right, to our new ones, alternate exterior and alternate interior. So for alternate, they are on opposite sides of the transversal. I need one from each side. So if I'm looking at my exterior angles, they are labeled for me here. Okay, so I'm looking at some combination of 1, 5, 4, and 8. Well, if they're alternate exterior angles, I could do 1 and 8. Those are on opposite sides of each other and on the outsides. I need one from each side. So angle 1 and angle 8 would work. I could also do 4 and 5. Alternate interior. This time I'm looking in between my parallel lines. Again, but I need one from each side. So I could do angle 2 and angle 7. Or I could do angle 3 and angle 6. Actually, I might write both of these just since we're still learning. All right, moving to same side. So this time I want either both on top of the transversal or both on the bottom of the transversal. First, looking at exterior angles, let's look at the top half of the transversal first. Exterior would be angle 1 and angle 4. If I looked at the bottom side of the transversal, I could talk about angle 5 and angle 8. Moving on to the interior, same side, I could do 2 and 3 coming from the top half, or I could do angle 6 and angle 7. So again, I think this would be a great thing to print off at home. If you can't print, maybe just draw yourself a picture and make this table either in your math notebook or on a piece of paper that you won't lose. This is going to be something great to have in front of you for the practice that we'll do next.